Hi everyone, welcome to the next exercise. This is exercise 4E and we're talking about gradient and direct proportion. Alright, when we talk about direct proportion, we're talking about a constant rate. Alright, so it doesn't change. So let's say one of the classic ones is a car traveling at a certain speed. So you would have the time going across, alright, time always goes across, and then we might have distance going up and the car progressing at a certain speed. All right. What you'll be given in these sorts of questions is some information. All right. Whether it's a car traveling at a speed or something else, it'll be something along the lines of that. So let's say we had a bucket of being filled with water. Okay. And at 1 minute, it fills up 5 liters. At 2 minutes, it fills up 10 liters. At 3 minutes, it fills up 15 liters. So then what we need to do is create a rule for the amount of water in that bucket, and from there we can graph it, and we can also solve some different problems. So the first thing we want to do is just create a bit of a graph. So we would have the y and the x, and that's going to be t, and this is going to be the number of liters, and we'll have the number of minutes, 1, 2, 3, 4, and then the liters going up the side, 5, 10, 20, 25. All we need to do then is just plot them. I might change that to red. Plot them. At 1 minute there's 5. At 2 minutes there's 10. At 3 minutes there's 15. And then of course at 0 minutes the bucket would be empty. So from there we can create a line. Okay. What we can then do is work out our gradient. So if we had something like our run is 1, 2, 3, and our rise is 5, 10, 15, we can say that m equals rise over run, and you need to write all this down, and that equals our rise of 15 over 3, which equals 5 liters per minute. All right, so that's our rate. All right, we can then create a formula. All right, so we know that the rate is 5 and it starts at 0. So the volume, how many liters it is 5 times the time. Okay, and then from there what we can do is work out any possible outcome. All right, so you'll get asked questions. If we know that this is our formula, we can use that formula to work out the volume after however many minutes. So if I create a new page and we know that it's V equals 5t, and the question I ask is how many liters will there be after 7 minutes? Okay, so t equals 7. That wasn't in our graph, but we can work that out really easily. V equals 5 times 7, which equals 35 liters. So we know how many liters there would be after 7 minutes, as long as we've got a big enough bucket, of course. The other thing that they might want us to work out using our formula is how long it takes to fill up, let's say, 100 liters. All right, so we would go 100 equals 5t. That's 5 times t. What's the opposite to times? Divide. So we need to divide both sides by 5. 5 goes into 120 times. So t equals 20. It would take 20 minutes to fill a bucket up with 100 liters of water if that was the rate. So they're the sorts of questions you're going to get asked. They're going to be different in regards to how it looks. It might be a graph that goes up like this. or it might be a graph that starts. So let's say a bucket emptying. So it might be full and then it's emptying and going down. All right. Or you might even get a bucket that has water in it at the start and then it's going up. All right. So there's different sorts of questions that you're going to get asked on this. The important thing is plotting it as a graph, figuring out the rate, and then creating a rule. Creating the rule is the most difficult part. Then you can substitute in and find out different amounts depending on what that equation is. But finding the formula is the most difficult part. All right. Please shoot me a message if you need any help. You can contact me through Teams. I'll talk to you later. Bye.